Tonight, a quiet idea from physics changes the meaning of goodbye, because the same laws that guide stars and galaxies also describe the final seconds of a human life. And those laws say that nothing truly disappears, not energy, not matter, not even the heat leaving a living body as it fades into the world around it. Yet hospitals still fall silent, hearts still stop, and people still speak about endings as if the universe suddenly closes a door. So a strange tension exists between what science measures and what humans feel. And this tension is where this journey begins, not with fear, but with curiosity. Because modern physics does not describe death as a single sharp moment, but as a slow shift from order into disorder, a transition written into the flow of time itself. And in this video, you will learn what actually happens inside the body at the level of atoms and energy when life stops. Why the laws of thermodynamics remain active even after the brain goes quiet, and how. Some physicists describe death not as a disappearance, but as a change in structure, a change in pattern, a change in how information flows through the universe. And as the story unfolds, ideas that sound simple at first start to feel deeper, because the same energy that allows a thought to exist cannot vanish into nothing. It spreads, transforms, and mixes with the environment in ways that are both ordinary and profound. And this is where many people misunderstand science, thinking that physics promises an afterlife or a hidden dimension of souls, while the real truth is more subtle and more powerful. Because physics does not deal in myths, it deals in measurable change. And those changes reveal a story that few people hear explained clearly, a story about entropy, about the arrow of time, about why living systems hold together for a while and then slowly release their order back into the wider universe. And step by step, you will see how the brain depends on tiny electrical things, patterns that require constant energy flow, how consciousness appears to rise from organized activity rather than from a separate, invisible substance, and why some theories suggest that awareness is less like a permanent object and more like a temporary wave moving through a physical system. And by the end of this video, you will understand what science actually supports and what it does not. Because many dramatic claims on the internet mix real physics with speculation, and separating fact from fiction changes the entire way death is viewed, not as a magical escape and not as a cold void, but as a transformation that follows the same cosmic rules that shaped the first stars billions of years ago. And along the way, you will hear about lesser-known insights that rarely reach popular discussions, such as how the atoms inside a human body were forged in ancient stellar explosions long before Earth existed, how every breath exchanges particles with the environment in a constant, invisible cycle, and how the energy released at the end of life becomes part of new physical processes, which means that while a person's unique pattern may stop, the universe continues to carry forward every physical trace. And this idea can feel unsettling at first, yet it also carries a quiet sense of connection, because physics shows that life is not separate from the cosmos, but deeply woven into it. And as this exploration moves deeper, questions about consciousness will appear, questions that scientists still debate with caution, because some researchers study information theory and suggest that awareness depends on complexity, while others explore quantum ideas that remain controversial and unproven. And you will see why honest science accepts uncertainty instead of pretending to know everything, which makes the journey more real and more grounded. And by staying until the end, you will gain a clear understanding of what happens when energy leaves an organized system, why conservation laws do not mean immortality, and how the language of physics can change the way endings are understood without turning them into fantasy. Because the goal here is not to replace emotion with cold equations, but to reveal how deeply the universe respects its own rules. And those rules tell a story that is both humbling and strangely beautiful. A story where death becomes a shift in perspective rather than a simple vanishing point. And as the final ideas come together, you may notice that the fear surrounding the unknown begins to soften, replaced by a sense of scale, a sense that each life is a brief but real expression of cosmic energy flowing through matter. And this understanding does not remove mystery. It transforms it into something more thoughtful, more grounded, more connected to reality. So if you are ready to explore what physics truly says about dying, what science knows, what it questions, and why the end of a biological process does not mean the end of everything that makes up a human being, then stay with this journey from beginning to end, because each section builds toward a deeper perspective that most people never hear explained in simple language. And if this kind of calm and honest exploration of science and existence speaks to you, welcome to our channel, where complex ideas become clear and where curiosity always leads the way forward. So take a moment now to subscribe and become part of a community that looks at the universe with open eyes and a thoughtful mind. Inside the human body, life depends on a constant flow of oxygen and energy. And the moment that flow weakens, the physical balance that keeps cells organized begins to change. The brain is one of the most energy-hungry organs, using a large share of the body's oxygen, even while the body rests. When oxygen supply stops, neurons lose the ability to maintain electrical activity. Tiny channels inside the cells stop working properly. Signals that once moved with precision begin to fade. This is not a dramatic instant, but a gradual physical shift. Electrical patterns grow weaker as chemical gradients collapse. The brain depends on organized electrical waves to maintain awareness, memory, and coordination. So when those waves slow down, the experience of consciousness changes as well. Physics does not describe this as a single switch turning off. Instead, it is a cascade of events where each system loses stability step by step. Cells begin to struggle to maintain structure. As these changes unfold, the body moves from a highly structured state toward a less ordered one. This shift is closely connected to the concept of entropy. In simple terms, entropy describes how systems move from order to disorder over time. A living body is an example of low entropy because its molecules are arranged in precise patterns. Proteins fold into exact shapes. Cells communicate through coordinated signals. The brain forms complex networks that allow thought and perception. Maintaining this order requires continuous energy input. When energy flow stops, the structure cannot hold itself together in the same way. Chemical reactions continue, but they no longer serve the organized goals of life. Instead, they follow the natural tendency of matter to spread out and lose structure. Physics sees this as part of the arrow of time. Entropy increases and processes move in one direction. Death, in this view, is not a single instant, but a transition where organized complexity slowly dissolves into simpler physical states. Many people picture death as a clear dividing line, yet physics describes it more like a fading signal. For a brief period, some cells may remain active, while others have already stopped. Electrical activity in the brain does not vanish at once, but decreases as energy reserves disappear. Chemical processes continue even after awareness ends, showing that the boundary between life and non-life is not perfectly sharp. This gradual change reflects how physical systems behave everywhere in the universe. Stars cool over time. Waves lose energy as they spread. Every organized structure eventually gives way to greater entropy. The body follows the same universal rules. There is no sudden removal of matter from existence, only a change in how that matter is arranged and how energy flows through it. Understanding this shift requires looking at the first law of thermodynamics, which states that energy cannot be destroyed, but only transformed. During life, the body converts food into movement, heat, and thought. Chemical energy stored in molecules powers muscles and fuels brain activity. When life ends, that energy does not disappear. Instead, it changes form. Heat leaves the body and moves into the surrounding air. Chemical bonds break down and return to the environment through natural processes. From a physical perspective, the atoms that once formed a living person continue to exist, and the energy that once supported complex patterns becomes part of other systems. This idea can sound comforting or confusing, depending on how it is understood. Energy continuing does not mean that a person's identity or memories continue. Physics separates energy from personal experience. The laws of thermodynamics describe transformations, not the survival of individual awareness. Body heat offers a clear example of energy transformation. While alive, metabolism keeps the body warmer than the surrounding environment. After death, that heat gradually spreads outward, following the natural flow from warmer to cooler areas. This process is simple but profound because it shows how physical laws remain active even when life stops. The same equations that describe heat flow in stars or machines also describe the cooling of a human body. Chemical energy follows a similar path. Molecules that once powered movement become part of new chemical reactions. Over time, they return to soil, air, or other living organisms, continuing the cycle of matter that has existed for billions of years. None of this requires mystery. It is a direct result of conservation laws that apply everywhere in the universe. A common misunderstanding appears when people hear that energy cannot be destroyed. Some assume this means that consciousness must survive in some form. Physics does not support that conclusion. Energy describes the capacity to do work, not the persistence of personality or thought. A living brain is not just energy, it is a specific pattern of activity. Memories exist because billions of neurons fire in organized sequences. When that organization ends, the pattern that produced awareness no longer exists in the same way. The energy remains, but the structure that gave it meaning changes. This distinction is important because it keeps the discussion grounded in science rather than speculation. The continuation of energy is a physical fact, while the continuation of experience is a separate question that physics has not confirmed. The topic of consciousness adds another layer of complexity. Many scientists approach consciousness from a brain-based perspective. According to this view, awareness emerges from the activity of neural networks. The brain produces patterns of electrical signals that correlate with thoughts, emotions, and perception. When oxygen stops reaching the brain, those patterns break down. Without energy to maintain electrical gradients, neurons cannot communicate effectively. As a result, experience likely fades because the physical processes that support it no longer function. This perspective treats consciousness as something that depends on the brain rather than something that exists independently from it. Evidence from neuroscience supports this idea, showing that changes in brain activity alter perception and memory. Injuries, anesthesia, and sleep all demonstrate how awareness depends on physical conditions inside the brain. Another approach explores consciousness through information theory. Some researchers suggest that awareness arises from complex information patterns rather than from specific biological materials. Integrated information theory proposes that consciousness depends on how much information a system can integrate and process as a unified whole. In this framework, a brain produces a high level of integrated information because its parts interact in intricate ways. When neural connections weaken or stop, the level of integration decreases and consciousness fades. This idea does not claim that awareness survives death. Instead, it describes consciousness as a property of organized systems. When organization disappears, the informational structure changes as well. The theory remains debated, yet it highlights how scientists attempt to understand awareness using mathematical models rather than spiritual explanations. Some discussions move toward quantum ideas, though these remain controversial. A small number of researchers have suggested that quantum processes inside neurons might play a role in consciousness. The ORC-OR model is one example, proposing that tiny structures within brain cells could support quantum states linked to awareness. Supporters argue that classical physics alone may not fully explain subjective experience. Critics respond that the brain's warm and noisy environment makes stable quantum effects unlikely. Experiments have not provided clear proof that quantum processes allow consciousness to continue after death. Most physicists treat these ideas with caution, emphasizing that speculation should not be confused with established science. The presence of debate shows that the field remains open to new ideas, yet it also highlights the importance of evidence and careful reasoning. When discussing death through the lens of physics, the focus stays on observable processes rather than metaphysical claims. Brain activity decreases as oxygen fades, electrical signals weaken, entropy increases as organized structures break down, energy transforms and spreads into the environment. Consciousness, as far as current evidence suggests, depends on patterns that require active brain function. Information theories attempt to describe how those patterns create experience, while quantum speculations explore possibilities that remain unproven. This layered view reflects how science approaches complex questions. Instead of offering a single final answer, it builds models that explain parts of the puzzle. Each model contributes a piece of understanding, even when uncertainty remains. The physical transition at the end of life also reveals how deeply humans are connected to the broader universe. The atoms in a brain once existed in ancient stars. The energy that powers a heartbeat comes from sunlight stored in food. When life ends, those atoms and energy continue to participate in new processes. This continuity does not preserve personal identity, but it shows that the boundaries between living systems and the environment are never absolute. Physics describes a constant exchange between order and disorder, between structure and transformation. A living body represents a temporary island of low entropy maintained by energy flow. Without that flow, the island slowly dissolves, merging back into the wider sea of physical processes. Scientists often describe life as a delicate balance between stability and change. Cells repair themselves, replace damaged molecules, and maintain internal order, despite the natural tendency toward entropy. Death marks the point where this balance can no longer be sustained. From a physical perspective, nothing supernatural is required to explain the transition. The same laws that govern chemical reactions and heat transfer guide every stage. Electrical potentials fade because ion pumps stop working. Molecular structures degrade because energy is no longer directed into maintenance. Over time, the body becomes part of the environment in a gradual and measurable way. This view does not reduce the emotional meaning of death. but places it within a broader scientific context. Consciousness remains one of the most challenging topics in science. While brain-based models offer strong evidence linking awareness to neural activity, the subjective nature of experience makes it difficult to measure directly. Information theories attempt to bridge this gap by focusing on patterns and complexity. Quantum ideas add another layer of speculation, though they remain far from consensus. Across all these perspectives, one point remains clear. There is no scientific proof that consciousness continues after the physical processes of the brain stop. This absence of proof does not claim that every question is answered. Instead, it reflects the current limits of knowledge. Science continues to investigate how awareness arises, but it does so by examining measurable phenomena rather than relying on belief. The idea that death is a process rather than a moment can feel surprising, yet it aligns with many observations. Medical research shows that different parts of the body cease functioning at different rates. Some cells survive longer than others. Chemical reactions continue even after awareness ends. Physics explains this by focusing on gradual changes in energy flow and entropy. Systems rarely switch from one state to another instantly. Instead, they move through intermediate stages where old patterns fade and new ones emerge. This gradual transition mirrors processes seen throughout nature, from the cooling of lava to the decay of radioactive elements. Energy transformation after death illustrates how physical laws remain consistent regardless of scale. The heat that leaves a body becomes part of the thermal energy of the surrounding environment. Chemical elements enter new cycles through soil and air. The conservation of energy ensures that nothing vanishes, yet it also reminds us that continuity of energy is not the same as continuity of self. The pattern that defined a person's thoughts depends on active organization. Without that organization, the same atoms and energy no longer form the same experiences. This distinction helps maintain a neutral and scientific perspective, separating physical facts from emotional interpretations. Exploring these ideas often leads to deeper questions about what it means to exist as a conscious being. If awareness arises from organized patterns, then life becomes a dynamic state rather than a fixed object. The brain constantly reshapes itself through learning and memory. Neural connections strengthen or weaken depending on experience. When the underlying activity stops, the dynamic process ends as well. Information theories suggest that consciousness depends on the richness of connections within a system. As those connections fade, the level of integrated information decreases, leading to a loss of experience. This approach emphasizes structure and interaction rather than mystery. Quantum speculations add an element of intrigue, yet most scientists remain cautious. The brain operates at temperatures and scales where classical physics provides accurate explanations for many processes. While quantum effects exist at the microscopic level, evidence linking them directly to consciousness remains limited. Some researchers continue to explore whether deeper physical principles could influence awareness, but these ideas remain hypotheses rather than established facts. The ongoing debate reflects the openness of science to new possibilities while maintaining a commitment to evidence. As the physical processes of dying unfold, the body becomes an example of entropy in action. Organized systems require constant input of energy to resist disorder. When that input stops, natural tendencies take over. Molecules spread out, structures weaken, chemical gradients equalize. This shift is not unique to humans. It occurs in every living organism and in many non-living systems as well. The arrow of time points toward increasing entropy, guiding the evolution of systems from structured beginnings toward more dispersed states. Physics describes this direction not as a loss of meaning, but as a fundamental aspect of how the universe evolves. The relationship between energy, entropy, and consciousness highlights how different areas of science connect. Thermodynamics explains the flow of heat and energy. Neuroscience studies the patterns of brain activity. Information theory attempts to quantify complexity. Each field contributes a piece of the larger picture. Together, they show that death can be understood as a transformation governed by universal laws, rather than as an isolated event outside the scope of physics. This perspective does not answer every philosophical question, but it provides a framework for exploring them with clarity and honesty. Within this framework, the fading of electrical signals in the brain represents a key moment. Neurons communicate through tiny voltage changes created by ion movement across cell membranes. Maintaining these gradients requires energy. Without oxygen, the chemical pumps that sustain electrical activity fail. Signals slow down and eventually stop. The loss of coordinated neural firing leads to the end of organized perception. While the exact subjective experience remains difficult to measure, physical evidence shows a clear link between brain activity and awareness. This connection forms the basis of the brain-based view of consciousness. Information theories approach the same question from a different angle. Instead of focusing solely on biology, they analyze how systems process and integrate data. A highly connected network can generate rich patterns of information, which some scientists associate with conscious experience. The human brain fits this description because its billions of neurons create a vast web of interactions. When these interactions weaken or cease, the informational structure changes. Consciousness, in this view, depends on complexity rather than on any specific substance. The theory remains a topic of active research, but it offers a way to describe awareness using the language of physics and mathematics. Quantum speculations attempt to push beyond classical explanations by exploring whether tiny physical processes might influence consciousness in unexpected ways. Some researchers suggest that quantum states could play a role in neural function. Others argue that such effects would be too fragile to survive in the brain's environment. The debate continues, showing that science is not a finished story, but an evolving conversation. What remains consistent is the lack of evidence supporting the idea that consciousness survives after death in a measurable form. Scientists acknowledge uncertainty while avoiding conclusions that go beyond available data. As these perspectives overlap, they create a complex yet coherent picture. The physical processes of dying involve the loss of oxygen, the fading of electrical activity, and the gradual increase of entropy. Energy transforms and spreads into the environment according to the laws of thermodynamics. Consciousness appears closely tied to organized patterns in the brain, with information theories and quantum ideas offering additional layers of exploration. Each viewpoint adds depth to the understanding of what happens when life ends, not as a sudden disappearance, but as a transition guided by the same principles that shape every part of the universe. From a wider physical perspective, some physicists use the phrase that death is not the end. Yet the meaning behind that sentence is very different from how people usually hear it. The focus slowly moves away from the idea of a single person and shifts toward the universe as a whole, because physics does not treat humans as isolated objects, but as temporary arrangements of matter and energy that exist within a much larger system. Every atom in a living body carries a history that began long before Earth formed. The carbon inside cells was created in the intense heat of ancient stars. The iron flowing through blood was forged during violent cosmic events that happened billions of years ago. Even the oxygen that fuels each breath was shaped by processes that existed long before any human mind appeared. When physicists speak about continuity after death, they often refer to this deep connection between life and the cosmos. The atoms that form a person are not new creations. They are part of an ongoing cosmic cycle that has no clear beginning or end. During life, these atoms organize into a complex pattern that allows awareness to emerge. When life ends, the pattern dissolves, yet the atoms remain, continuing their journey through new physical systems. This shift in perspective can feel unusual because everyday language focuses on identity and personal experience. Physics looks instead at energy flow and structure. A human body maintains order by constantly exchanging energy with its environment. Food provides chemical energy that keeps cells active. Heat leaves the body, balancing internal processes with the surrounding world. This constant movement of energy allows life to exist in a state of low entropy, meaning a state of high organization compared to the environment. Over time, energy naturally spreads out, moving from concentrated forms to more dispersed ones. Life exists because this flow continues. The sun provides energy that plants capture. Animals consume plants and transform that energy into movement and thought. When the flow stops, the organized pattern cannot remain stable. The system moves toward higher entropy, following the same universal direction seen in every physical process. Some physicists describe this transition not as a disappearance, but as a redistribution. The energy that once powered neural signals becomes heat that spreads into the air. Chemical elements re-enter natural cycles through soil and atmosphere. Nothing vanishes from existence. Instead, the universe continues evolving, using the same building blocks in new combinations. This idea can sound poetic, yet it is rooted in simple physical laws. The matter that forms a living being has always been part of the cosmos. It does not belong to one moment in time. A person can be seen as a temporary pattern formed by energy flowing through matter. When that flow changes, the pattern fades, but the underlying material remains active within the larger system. The concept of entropy helps explain why life appears and disappears within the universe. Low entropy systems are highly organized. High entropy systems are more disordered. Life exists because energy moves from concentrated sources to more dispersed states, creating pockets of order along the way. A living organism captures energy and uses it to build complex structures. Over time, entropy increases, and maintaining that structure becomes more difficult. This is not a failure of life, but a natural consequence of physical laws. The arrow of time moves forward because entropy grows. Stars burn their fuel, planets cool, biological systems age. The universe itself evolves through these processes, constantly transforming while conserving matter and energy. In this context, the phrase that death is not the end refers to the continuation of physical processes rather than the continuation of personal identity. The pattern that defines a person ends when the organized activity of the brain stops. Memories, thoughts, and subjective experiences depend on specific neural structures. Without those structures, the same arrangement cannot exist. Yet the matter that formed that pattern continues to exist in new forms. Some physicists find meaning in this continuity because it highlights how deeply humans are connected to the cosmos. The atoms that once formed a brain may later become part of soil, air, or other living organisms. The energy released during life contributes to the ongoing movement of the universe. Misunderstandings often arise when people hear scientific ideas without context. One of the most common myths involves the conservation of energy. The first law of thermodynamics states that energy cannot be destroyed. Some interpret this as evidence that consciousness must survive after death. Physics does not make that claim. Energy describes a measurable property of systems, not the persistence of identity or awareness. A living brain is not just a quantity of energy. It is a specific arrangement of electrical activity. When that arrangement ends, the experience associated with it also ends, as far as current science can tell. The energy remains, but it no longer forms the same organized pattern. Another misunderstanding appears when physics is mixed with spiritual language. Some discussions suggest that science confirms the existence of souls or hidden dimensions where consciousness continues. Physics does not provide evidence for these ideas. It studies measurable phenomena and builds models based on observation and experiment. While many people hold personal beliefs about life after death, those beliefs exist outside the scope of physics. Maintaining this distinction allows science to remain honest and grounded. At the same time, physics does not claim to have solved the mystery of consciousness. Researchers continue to explore how awareness arises from physical systems. New theories appear, some focusing on neural networks, others on information processing or deeper physical principles. The absence of a complete explanation does not mean that any specific claim is true. It simply shows that the field remains open to discovery. Balanced credibility comes from acknowledging both what science knows and what it does not know. Physics explains how matter behaves, how energy flows, and how entropy increases. It provides detailed descriptions of chemical reactions, heat transfer, and the structure of atoms. Yet it does not fully explain subjective experience. The feeling of awareness remains difficult to measure. Scientists can observe brain activity and correlate it with behavior, but the inner quality of experience remains a complex question. This uncertainty invites careful thinking rather than dramatic conclusions. Some ideas about consciousness explore information patterns, suggesting that awareness depends on how systems integrate data. Others investigate whether deeper physical laws could play a role. Each approach adds insight, yet none has provided proof that personal awareness continues after the physical processes of the brain stop. As discussions move toward a more philosophical tone, the perspective of physics begins to reshape how meaning itself is understood. A human being can be seen as a temporary pattern formed by the universe. Matter organizes itself into complex structures through natural processes. Over billions of years, simple particles formed stars. Stars created heavier elements, and those elements combined into planets and eventually into living systems capable of thought. In this sense, consciousness becomes a way for the universe to observe itself. Complex arrangements of matter allow information to flow in new ways, creating awareness as an emergent property of physical interactions. This idea does not require mystical explanations. It simply reflects how complexity can give rise to new behaviors within physical systems. Viewing life through this lens changes the way endings are perceived. Death becomes less about disappearance and more about transformation. The viewpoint created by a living brain ends, yet the material that made that viewpoint possible continues to participate in the larger story of the cosmos. The universe keeps evolving, forming new structures and new patterns of energy. Stars collapse and give birth to new stars. Galaxies merge and reshape themselves. Biological systems appear, adapt, and eventually fade. Each stage contributes to the ongoing flow of time and entropy. The meaning of existence shifts from permanence to participation in a vast and changing process. Some people find this perspective unsettling because it removes the idea of a fixed, unchanging self. Others find it calming because it emphasizes connection rather than isolation. Physics shows that every living being is part of an immense network of interactions. No atom exists alone. Every particle interacts with fields and forces that extend across space. The same laws that govern the motion of galaxies also govern the chemistry inside a human brain. This unity between the smallest and largest scales creates a sense of continuity that goes beyond individual lifetimes. When discussing these ideas, many physicists choose their words carefully. They avoid language that suggests certainty about topics beyond current evidence. Instead, they describe possibilities and limitations. The continuation of matter and energy is well established. The continuation of personal consciousness remains unproven. Maintaining this balance helps prevent confusion between scientific fact and philosophical interpretation. It also allows space for reflection without turning the discussion into a claim about ultimate truth. The philosophical aspect of physics often explores how meaning arises from temporary patterns. A wave exists because energy moves through water in a specific way. When the energy spreads out, the wave disappears, yet the water remains. Some thinkers use this analogy to describe life. A person may be seen as a wave of organized activity moving through matter and time. When the conditions that support that activity change, the wave ends, but the underlying material continues. This view does not reduce life to something insignificant. Instead, it highlights the rarity and beauty of organized complexity within a vast universe. As awareness develops within living systems, the universe gains new ways to experience itself. Through complex brains, matter can reflect on its own existence. Thoughts, art, and science emerge from interactions between neurons and energy flows. From a physical perspective, these experiences are part of the natural evolution of complexity. Death, then, may be understood as the end of a particular viewpoint rather than the end of matter or energy. The universe continues to change, forming new patterns that may also give rise to awareness in different forms. Throughout this exploration, it becomes clear that physics invites humility. The laws of nature reveal patterns that extend far beyond individual lives. Stars live and die on timescales that dwarf human history. Galaxies evolve over billions of years. Against this vast background, a human lifetime appears brief, yet it carries significance because it represents a rare state of organized complexity. Understanding this does not remove emotion from the experience of loss. Instead, it provides a broader context that connects personal stories to cosmic processes. As discussions deepen, the idea of identity begins to shift. Instead of viewing the self as a fixed object, physics encourages thinking of it as a dynamic process. The brain changes constantly, forming new connections and losing old ones. Memories evolve, perceptions shift. The sense of a stable self arises from continuous patterns of activity rather than from an unchanging core. When those patterns end, the viewpoint they created ends as well. Yet the matter and energy that supported them continue to exist, participating in new processes that shape the future of the cosmos. This perspective leaves room for reflection without offering final answers. Physics explains how systems behave, but it does not dictate how individuals interpret meaning. Some people find comfort in the idea that they are part of an ancient and ongoing cosmic cycle. Others focus on the uniqueness of individual experiences during life. The strength of a scientific approach lies in its willingness to explore questions without forcing conclusions beyond evidence. By recognizing both the power and the limits of physics, it becomes possible to approach the topic of death with honesty and depth. The universe continues to evolve regardless of individual lifetimes. Energy flows through stars, planets, and living organisms, creating patterns that appear and disappear over time. Each pattern adds complexity to the overall structure of reality. From this viewpoint, death may be seen as a transformation in perspective rather than a final end to existence. The matter that once formed a conscious system remains part of the cosmic process, contributing to new structures and new possibilities as time moves forward. And when everything becomes quiet again, physics leaves us with a gentle truth that feels both small and endless at the same time. It does not promise forever, and it does not turn mystery into easy answers, yet it shows that every atom that builds a human life has already traveled across stars, across time, across unimaginable distances, and will continue moving long after one single viewpoint fades away. The universe does not pause or erase what once existed. It transforms it, reshapes it, and carries it forward into new forms that we may never see, but are still part of the same ongoing story. In that way, death stops being a simple ending and starts looking more like a change in pattern, a moment where one arrangement of energy closes while the larger flow of existence keeps moving without silence or emptiness. Maybe meaning is not about lasting forever, but about being a brief and real expression of a universe that is always evolving, always creating, always turning simple particles into moments of awareness that can ask questions about their own existence. And as this journey reaches its final words, let that idea stay with you for a while, not as fear and not as certainty, but as a calm reminder that you are part of something far bigger than any single lifetime. If this perspective made you think in a new way, support the channel by subscribing, press like so more curious minds can find these ideas, and share this video with someone who enjoys deep but simple explorations of science and reality, because every small action helps this space grow and keeps these conversations alive.